just wanted to run through a quick summary of what's expected of you in this chapter, and it's pretty straightforward, I would have thought, but we'll just run through to make sure that everyone is clear on what's expected. So first thing that we can look at is the idea of primary or secondary data. So with primary data, like a primary source or a secondary source that you've got in history. Primary source is from the source itself or something that you do. So if you remember, on a primary source in history, you talk about like a diary entry from someone who was at an event or pictures from the scene. And then a secondary source would be someone who's written a book about an event even though they weren't there. So if I wrote a book about World War II, that would be a secondary piece or a secondary piece of evidence. When we get our data for any kind of statistical investigation, it's very similar. When we talk about getting primary data, is data that we collect ourselves. So we collect that ourselves. And the secondary data we collect from somewhere else, so we get it from another source. Okay, it doesn't matter where that is, could be anywhere, from the census or from information that's given to us in loads of different ways. Okay, so that's our primary and secondary data. Then we have to look at the idea of the data types, and this is the next most important thing I think in this chapter, to be honest. So you can see we've got two types, categorical and numerical. All right, so when we're talking about categorical, we're talking about categories. So if you were asked about a category of something, so if you said like categories of TV shows, you could have a cartoon or a soap opera or a drama or whatever. Okay, so there's loads of different types of those things. And when we're talking about numerical data, we're talking about numbers. There's numbers involved in that data, that information. Okay, so each of these have two branches. You can see we've got 1, 2 for categorical, 1, 2 for numerical. Okay, and I want to look at the categorical ones first because they're the ones that are a bit more straightforward. You can see nominal has to do with the names of things. Okay, so and ordinal then has some order on it. So it's important, I suppose, to kind of compare these to one another. If you look at nominal and ordinal has an order on it, nominal does not, essentially. Okay, so when we're talking about nominal data, it's like the example I just gave you. I've given you an example question of what that would look like that would collect nominal categorical data for you. What is your favourite type of movie? Comedy or action or horror? So I could tick any one of those, whichever one is my favourite. Okay, you tick one of them, doesn't matter. I can't say that comedy is better than action or is better than horror. I can't put one above the other. Now, in your own head, you might like one of them better, but I can't say that for definite. Comedy films are better than action films, so comedy have to go at the top and action have to go next and horror have to go next. That's not the case. So that's what's happening with nominal data. We can't put any order on them. I can't say one is better than the other. With ordinal data, as we've just mentioned there is an order. So you can see in example 2, I've got, how would you describe your understanding of this topic? There is an order in all of those answers. I can see excellent, very good, good, fair, poor. I can pick whichever one I think. If I understand this very well, I could say very good. I know that very good is below excellent, but I know that it's above good. It's better than good. It's very good. Same way, they have an order. This would be number 1. This would be number 2, 3, 4, 5. Poor is the worst. And as you improve, you can move up the numbers. So that's why we can see that there is an order on this data, because one is better than the other. Compared to the movies, if you look at them. I can't say that a comedy is better than an action is better than a horror. You might have your own preference on that, but you can tell for sure in this question that one thing is better than the next. Going on to numerical data then, I've got numbers involved the whole time, as I've mentioned. With continuous data, there's lots and lots of different intervals. Okay, generally we get these things from doing some kind of measurement. So as you can see in example question 3, I've just said, what is your height? Now you're going to write down a number answer for that question. It could be written in loads of different ways. So I've given you a couple of examples. You can imagine if I write, I'm 180 centimeters tall. I'm 1.8 meters tall. I am 6 foot 1 inch tall. 3 different ways of writing the same thing, but we could have lots and lots of different parts that split up there. Okay, so as it's continuous, I can continuously change what's being measured, or I can break it down to be smaller and smaller. As I said, I could measure it in meters, then in centimeters, then in millimeters, and I can break it up. You can imagine if I have 2 people who are really similar height, I could say that they're both 6 feet tall. But then if you wanted to tell for sure which one is taller, I could go and measure in centimeters, because that's a smaller unit. And if they are very similar there, I could start measuring in millimeters, and then I should be able to tell a difference between the two. So when I'm talking about continuous data, that's what's happening. I'm trying to split up every piece of data that I get as specifically as I can. Finally then, with discrete data, is really simple, okay? As I said, usually we've got set intervals or values. So it's usually whole number answers, essentially. That's all that's being asked, okay? So you can see in example 4, how many people are living in your family home? That could be 4, could be 5, could be 2, could be whatever. It's just a set number. I can't have 4.5. I can't have 10.2. I can just have 1 or 2 or 3 or 4 or 5 or whatever number, but they have to be whole numbers in that case. And usually discrete data would be whole numbers. So that's the 4 different types. To move on from there then, the thing that you want to look back at is the idea of a frequency table. So we talked about getting data. As you said, you can have people picking their favourite colour. So people pick red or blue or green or yellow. This is what type of data? It is categorical nominal, because there's no order. I can't say one of those colours is better than the other. You can imagine I asked a group of people, and 5 of them said red, 4 of them said green, or blue, 9 of them said green, and 11 said yellow. That is a frequency table. I've given my information. Done. That's it. I can also write that as a tally. And remember, we do it in groups of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we just count it out like that. Alright? That's all there is to it. So just be careful. Take your time. Pause the video. Go back and look at whatever you need to make sure you're clear on what's happening. Thank you very much.